Okay, everybody, today I want you to be a color chemist to figure out what colors are hidden inside of your favorite markers. Now, I bet a bunch of you are saying, Mrs. Hattier, I can tell by the cap that it's purple. I do not need chemistry to figure that out. And you're right, it's purple. It's a purple marker. You're exactly right. But what you might not know is that hidden inside of this purple marker are a whole bunch of other color molecules. So when a marker is made, they use different color molecules to make this exact shade of purple. And the color molecules that they use for this purple are different from the ones that they would use to make this purple, or this purple, or this purple, or this purple, or this purple, and so forth. So even though they're all purple, there are different color molecules used to make each of them. And in this experiment, I'm going to teach you a technique to figure out what colors are hidden inside each marker. So purple or a whole bunch of other varieties. The technique is called chromatography. Now I'm going to say it one more time because that's a big word, but it's chromatography. And all that is a way of separating things that are too small to pick up with your hands. So it's sorting. You know what sorting is. We do it in our classroom all the time. We sort red and yellow and green into different bins or by different shapes. This is the same thing. It's sorting things that are all mixed together. But here you can't pick up the different color molecules with your fingers. So you're going to use chromatography to separate the colors from each other, okay? And it is a very easy and fun experiment, and you don't need very many things for it, okay? So here's what you're gonna need. It's a very short list of supplies. You're gonna need paper towels. This is my favorite for this experiment, but if you don't have paper towels, you could also use coffee filters, okay? White would definitely be best so that you can really see the different colors show up on the white, okay? Then you need scissors, and you need the smallest little bit of water possible in any cup you want. Does not matter for this experiment. And then you need a whole range of markers. Now, when we're in the classroom, people always want to try this color, and this color, and this color, and, this color is a popular one. You know, it's funny, on the screen, these look exactly the same. So it's purple and blue, but there we go, that's better. Okay, these are super popular colors, and I get it. They are beautiful. So test them, for sure. But what I would like you to also do is pick a wide range of colors and try to pick the colors that you might not normally pick. So, for example, nobody ever wants to do this one. What color is this? That's right, gray. It's not, when I offer you the whole basket, nobody ever wants to pick this one, but it's really fun for this experiment. And so is this color, black. And just pick colors that you might not normally pick, like this kind of mossy green, this kind of, I don't know. I don't even know how to describe it. Maybe you can think of a description. I draw a blank on that one, right? So choose a huge range of color, not just the popular ones, but really try to find some unusual colors because they turn out really beautiful for this experiment. Now, the one rule when selecting your markers is that they have to be water soluble. So no Sharpies for this experiment. The other thing that does not work well is dry erase markers. If you have those are not super successful. So you want your regular old water soluble coloring book markers, okay? Now, here's what you're gonna do. The very first step is to take your paper towel and to just cut it into a thin strip. The size does not really matter. The only criteria is that it has to fit inside of your cup, okay? And then what you're gonna do is you're gonna take your marker. I'll start with purple since we were discussing that. And you're gonna draw a line down close to the bottom. So it would look like this. So you don't want it all the way down at the bottom, but it's definitely closer to the bottom than the top. And it's not even halfway, right? It's close to the bottom. So that's what you want to do. Now sometimes if a line is super hard for my younger friends, you could do a dot. It doesn't work as well though. And I know that you guys have been practicing drawing your lines, so give it a try. One line. Also, the one thing I want to say is one line, not 2 lines or 3 lines. I hate to stifle your creativity, but for this experiment, one line across the bottom, okay? Now, what we're going to do is we're going to take this paper towel and we're going to dip it into the water such that the line does not get wet. So you want to dip it in, but you don't want it to go so far in that this line gets wet, because if that happens, it just diffuses straight into the water and you got to start again. I mean, it's no big deal. You just have to start again. So you don't want the line to get wet. You don't want to dip it in the water. The way this experiment works is the same way our walking water rainbow experiment worked. So do you remember what we did there? It was called capillary action. Do you remember that big term? And all that meant was when water, any liquid, but for us, water, moves up something against gravity. So the examples I gave you were water moving up a straw, water moving up from the roots to the other parts of the plant, or water moving up a paper towel. Okay, so this works exactly the same way. So you're going to take your water and your paper towel with the one line on it, and you're going to dip it in, making sure the line doesn't go into the water. And you're just going to hold it there. And if you wait, you could count to 10. You could practice your counting to 10. And you're going to start to notice your line changing. So I'm going to pull this out. Okay, so can you see the change that's occurring to my line? It started as a nice thin line of only purple, and what do you notice happening? That's right, it's getting wider, isn't it? And if I move closer, you might be able to see that while it started as just purple, other colors are now appearing. So what colors do you notice appearing? I'm starting to see some pink at the very top. How about you? Do you see that pink? And I notice at the bottom, it looks blue to my eye. I don't know how it looks on your screen, but I'm really starting to notice 2 colors appearing, pink and blue, or red and blue, you might say they are. And does that make sense to us in the classroom when we mix red and blue together? Do they make purple? Yeah, it kind of makes sense, right? So we see red and blue appearing from our purple line using chromatography. Now, you can do this with all kinds of markers, and you get some beautiful results. I'm going to show you one, and then you're going to make a prediction as to what color I started with. So here's the final product, okay? Those are the 2 colors that it turned into. What are they? What do you see at the top? Blue and yellow. What color do you think that started as? If your guess was green, you are right. That started as a green marker, and it's separated out into blue and yellow. So, how this works, capillary action, you know, the water moves up the paper towel. And as it does that, it kind of grabs on to the color molecules and pulls it with them. And the heavy molecules stay towards the bottom. So yellow is heavier than blue, so it doesn't move as far up the paper towel. And then the blue is at the top, so it must be lighter. It's kind of like if you had to drag a feather or an elephant up a ladder. Which one do you think would be easier to get up the ladder? The feather, right? So the blue is kind of like the feather. It's able to get up higher because it's lighter. And then the yellow is kind of like the elephant. It's much harder to drag up that paper towel ladder. Okay, that's capillary action, and it results in the colors separating from each other. So you can do that with a ton of different markers. We went crazy last night. We went crazy. Like, I'll just show you, so here's one board of them we tried. Here's another board of them we tried. We just kept going. We kept going and kept going and kept going. The other thing that you could try doing with this is you could try to draw lines right on top of each other. So pick a bunch of different colors. So I'm going to take purple, and I'm going to draw that on top, one line. And then right on top of it, I'm going to take orange, and I'm going to draw it on top of my line. And then I'm going to take green, and I'm going to draw that on top of the line. And then I'm going to take my favorite color, which is Yellow. And I'll draw that on top of the line, okay? So see, I had picked a bunch of different colors, but they're all right on top of each other. And you can see if you can separate them from each other. So now when you dip it, you can see if you can separate all those different colors out from each other and what kind of color pattern those make. So there you have it. This is called chromatography, and it uses capillary action. So you're now a color chemist. So super easy experiment. Try lots of different markers. Remember, sometimes less popular colors produce really beautiful results. So try a huge range. Let me know what you think. And until next time, have fun and be well. Bye-bye.